Hi, today we will be presenting the pre-phase A of the Unit Transportation Fridge capstone project. The team is composed by Madeline, Malavé, Paola, Contreras, Jenylis, Vega, and Oasis, Rodríguez. The items to be discussed as part of the agenda are the following: users and stakeholders, background information, concept of operations, project description and objective, project significance, preliminary system level, including measurements of effectiveness and measurements of performance. Also, the project planning.
This product will have a great variety of potential clients. They are a possible source of future income, since the design of the project is for their benefit and growth. This product will be useful for laboratories, vaccine centers, blood banks, and other medical facilities. Nobody will really be affected by the creation of this product. On the contrary, it will be a product that is going to contribute in a positive way for both the customer and the patient. Since, as I mentioned before, the manufacturing companies and the entire medical system will take it as an action of response to a situation that they present daily. On the other hand, it's very likely that when the customer sees this product, they will not discard the portable unit they currently use. But I understand that they will stop buying them. In the medical field, the portable coolers are used to transport different materials used in this field. This cooler creates a durability to the product while it can reach its destination. It is used for vaccine, blood units, COVID tests, medicines, organs, among other additional functions. These aforementioned products need to remain at a certain temperature in order not to be affected. For example, blood units and plasma must be at 0 to 4 degrees Celsius. If these units are not at that temperature before transfunctions, they could use oxygenation and carbon dioxide to be transferred to the human body. On the other hand, this cooler is very similar to what is known as a beach cooler, as they tend to be made of plastic or hard foam. Although these coolers already exist, they cannot be used effectively because they use plastic bags with a type of cool gel, which after several hours begins to melt. In addition, they tend to use dry ice to create durability in the product, but as an effect, this ice is gaseous and release chemicals that can cause burns and irritations in the body of the person who is going to handle it. In turn, temperatures should be monitored with thermometers every hour or less, depending on the product in the cooler. The process that is carried out using these portable units is as follows. First, the product is placed inside the cooler. Then, the product is transported to the facility that will use it. When the products arrive, it's inspected to verify that it's in excellent condition. But in addition to this, while it's in the process of being transported, it must be monitored. Finally, the product could be used. The objective of this design is to create an effect of quality and durability during the way that will present the product. The plan is to monitor this cooler through an application. In addition, we'll not be using chemicals or materials that can thaw quickly.
The description of this project is to design a portable and easy-to-use unit transportation fridge for the transport of medical materials such as, for example, blood unit, platelet units, samples, drug, hormones, or other medical products. The objective of this project is to design a unit transportation fridge that is able to maintain an adequate temperature within a range of 0 degrees to 24 degrees Celsius for the transport of units. The temperature range was chosen in order to be able to transport a wide variety of medical products.
As a relevance for the project, we want to develop a secure and trustable way to transport and maintain in optimal conditions medical-grade products used in the medical industry. In the actuality, the fridges available in the market are expensive and have limited options for proper transport and conservation of medical material. This means that a portable fridge can only be used, for example, for carrying blood samples and nothing else. Due to its cost, healthcare centers may decide to use a less ideal portable fridge as the beach coolers. These coolers have a certain error range causing the temperatures to vary and not to stay constant as they are required by the product being transported at the moment. It is intended to develop a portable fridge that can be adjusted by the client to be used for multiple medical products, reducing the cost of buying different portable fridges and maintaining optimal conditions as required by being controlled by an application that we intend to create. Here in the right corner you can see an example of what the beach coolers are. According to a report written by Future Market Insights, the market for biomedical fridges and freezers will increase at an annual rate of 5.9% in the next 10 years. The biggest reason being the increase of the necessity to maintain the integrity of the product transport on the selected container by the client. In 2020, this market was estimated to be valued on $3.2 billion US. If the increase rate mentioned before does not change, the market will be valued on approximately $6 billion by the year 2031. In the actuality, North America holds the first position in this market, and it is expected to continue this way for the next 10 years. Some of the companies on the industry include Thermo Fisher Scientific, Biomedical Solutions, Panasonic Healthcare, among others. One of the main problems with the fridges used in the past years is related to climatic changes on Earth. Temperatures rising have an adverse effect on these portable fridges, making them less effective maintaining the adequate temperatures for the required time, causing adverse reactions and waste of product because of thermal shock. At the same time, this problem also causes a substantial amount of money loss because of the lost product. Being able to control the temperature through the application will result in less product and money loss. Another aspect to consider is the fact that clients tend to select refurbished products because of their lower price. This trend also affects the integrity of the product, resulting in money loss. Another detail to take into consideration is that portable medical fridges came with settings for a specific product, making the client buy multiple portable fridges for different products. Here in the right corner, we can see an example of the medical grade portable fridge provided by one of the companies. We can see here that this one is strictly used just for blood units or RPC units. Every healthcare center in need of a portable fridge can be a potential customer. According to Future Market Insights, the demand for these fridges have increased due to the increasing demand for blood transfusions, custom-made medicines, vaccines, and cellular therapies. With these details in mind, a potential customer can include blood banks, laboratories, research centers, hospitals, universities, among others. Measurements of effectiveness: we have to take into account capabilities for the product. This means that the fridge has to be able to contain multiple units of the same product at once in the trusty conditions, and temperatures. The constraints: it has to be considerable weight for its handling and has to have optimal measurements to be transported on the vehicle. Also, as a key assumption, it will be used for long periods of time, and in the external interfaces, it has a cable port for battery charging, a display for temperature, and a wireless connection to the controller application. These details will be explained more in depth by Madeline Malavé.
And now we will continue with the measurements of performance, commonly known as MOP, which come after the MOEs, which were the measurement of effectiveness, that are the requirements the client, internal and external, made to us. For example, when one of the requirements was that it shouldn't be too heavy, it shouldn't be easy to handle, and it shouldn't be very bulky. Therefore, we have to use the average measurements of the portable refrigerators available in the market, which are 44.5 by 39 by 23 centimeters. It needs to have a handle. We will have a mobile application that will be new to the market, in which we will be able to control the alarms, the temperature for each unit, and we're saying that it will be chargeable. Therefore, we need a port of 12 volts to connect to the electricity. Shouldn't be too heavy. The 50 pounds will be the maximum of when the unit is empty. The materials should keep the temperature low within the desired range. Therefore, those materials must be insulated. Continuing with the MOPs, we have that the product must be waterproof and leak-proof to maintain a constant temperature. The charging time must not exceed 4 hours, and time between charges must not be less than 10 hours, because sometimes the product will need to travel long distances. With the mobile application, the alarms should sound when the temperature is going outside of the range, too low or too high. And sometimes the alarm may sound multiple times until the issue is resolved. And at last, we will have an alarm that will alert the user when the time of charge is running out, starting from 2 hours before the battery runs out until the last 10 minutes of battery. After having established which are the MOEs and which are the MOPs, the QFD was created. That will be the quality function deployment. This diagram combines the relationship between the measurements of effectiveness with the measurements of performance and gives a value. For example, we listed the MOEs in the left side under the name requirements, and then we added the weights based on the importance the user told us. On the top, we'll have the MOPs that are how we will accomplish the requirements the user stated. At the top, we have some arrows, and those symbols, they just stated that when that MOP goes up, increases, that will be good for us. For example, if the size of the handle increases, that will be better because it will be easier for the user to carry the product. For example, the times between chargers, if we decrease those times, it will be better for us. At last, we calculate the relationship between the MOEs and the MOP, and that give us the total values. And based on those numbers is how we will work, what we will need to improve, and what will be ready.
Thanks for listening to the Pre-Phase A presentation. Now we have a high-level summary of the tasks for the Phase A, which is the next phase. The tasks are the following: technology assessment, trade studies, project mission, architecture and interfaces, budget, subsystem requirements, subsystem risk assessment, project plan, and the submission, which is on the first week of October 2022.